Hello friends. So in this tutorial we are going to learn about stacks. Stack is a data structure and is an abstract data type and is an ordered list in the data structures. So what is stack? What operations we are going to perform in this stack? Stack looks like this. The bottom is closed and the top is open. Here we can insert the elements, that is nothing but pushing. We can remove the elements, that is nothing but popping out the elements. In stack, insertion and deletion takes place, insertion and popping, that means pushing and popping takes place at only one end. And always the top is in active position. And bottom is in inactive position. And in stack, when we insert the elements, for example 1, 2, 3, when we insert the elements 1 will be stored here, again 2, 3. So the last inserted element is 3. It will be popped out first. That is, it follows LIFO rule. That is last in, first out. For example, most common example for stacks is the daily example, real-time example is bangles. For example, we have a bangles rack and we have many bangles over here. If you want to remove this bangle, we have to remove this one and next this one and next this one. This is the last inserted one. So this last inserted one will be removed first. In this way, we name it as last in, first out. The operations which we are going to perform on this stack is push and pop. And for stack, we have two conditions. One is, we have to check whether the stack is full or not. That is, if this top will be the highest element. So we have to check for top equal to n elements or not. We will give the size of the stack, for example n equal to 5. Then if top equal to 5, then we have to say stack is full. And second condition is, we have to check whether the top is empty or not. If top equal to 0, or we can check top equal to -1, then we say stack is empty. And the ADTs for stack are, we'll check for is full, is empty, and insertion, that is push off, insert or push off, and delete or pop off, and displaying the stack elements. These are the ADTs of stack. And how we implement this stack? We can implement this stack in two ways. One is using arrays, second is using linked list. So first let us see with arrays. Let's take a list of 4 elements, 1, 2, 3 and 4, and size of stack is n equal to 4, so that we can insert 4 elements. So how we gonna do push operation? Insertion is nothing but push operation. First let's take a table kind of thing for brief explanation. Stack operation. What operation we are going to perform, whether it is push or pop, we will be writing over here. And the stack before operation, before push or pop operation, how the stack looks like. Then next, what is the algorithm invoked? We need to write algorithms for this push and pop, for this insertion and for deletion. Like I said, these conditions, right? If top equal to n, we have to check these conditions, and based on that, if stack is full, we can't insert any element. If stack is empty, we can't pop out any elements. So we have to check for these elements and we have to insert the element. So what algorithm is invoked, or what algorithm we used? Next is stack after operation. How it look like? Now stack operation, push of 1. So stack before, how it looks like? 0, 1, 2, 3. As I said, size of stack is 4. What algorithm we invoke? This is push off. Here we write, for example, name of this stack is S. Let's name this stack as S. So we write the name of this stack as S. Size of the stack is 4, and where we are going to insert is at 0 index. What element we are going to insert is 1. So this is index, this is data, this is size, and this is name of the stack. After stack operation, how it looks like? Now again push off 2. How this stack looks like? 1, 0, 1, 2, 3. After the algorithm invoked S 4, here index at 1 we are going to insert element 2. Now how this stack looks like? 1, 2, 0, 1, 2, 3. Now push 3. How this stack looks before? 1, 2, 0, 1, 2, 3. Push off stack name, size of the stack, index is 2, element is 3. So after operation, stack look like this. Now push 4, element 4. How the stack looks like before is like this. Now S4 at third index, element is 4. Now the stack looks like this. Now as all elements are pushed in, let's go with pop operation. Here pop off. What we have to pop now? The last inserted element in the stack is 4. Now the stack look like this. 1, 2, 3, 4. This is the top element. So I said last in, first out. So it should pop 4. For pushing, what element we have to push? We have to give it as push 1, push 2 or push 3. For popping, no need to give the number. It automatically pops out the last inserted element. So if we give pop, how this stack looks like before is 1, 2, 3, 4. After pop operation, for pop operation, no need to mention the size, as it doesn't care about the size. It just cares about whether stack consists of any elements or not. It checks the condition if top equal to 0 or equal to -1 or not. If it is not empty, then it pops out the element. So name of the stack, in which index is 3, and here element is 4. Now stack after operation is 1, 2, 3. Again pop. Stack before operation is looks like this. Now pop is here index 2 and element 3. Now stack after operations look like this. Now again pop. Stack before operation looked like this. Pop of S. You have to remove the first index element and element 2. Stack after operations look like this. Now again pop. One stack before operation look like this. Now we have to remove stack S, element at 0 and element 1. So stack after operation look like this. Again, if we take pop operation and if we see, this is stack before operation is empty. Now if we take pop, as this is empty, it says stack underflow. When there are no elements in this stack, then it says stack underflow. When there are more, when the stack is full, it says stack overflow. As I said that in arrays we can store the stack elements like this. How we store this in linked list? Linked list is common thing as we know. For example, single linked list. 1, element 1, element 2, element 3, element 4 connected to each other. Its address is stored here, its address is stored here, its address is stored here, and last element is null. In this way we can do for double linked list, circular single linked list, and circular double linked list. So in this way we can store the elements in this stack. We can push the elements into the stack and pop the elements into the stack based on the conditions. Conditions are nothing but whether the stack is full or empty. So in the next tutorial we are going to learn about the applications of stacks. So if you like this video, please do like, comment, share and subscribe, and please do click on the bell icon so that you will get to the notifications about new videos which we upload. Thank you.